Okay, so if we think about at the beginning of the year, we were talking about quadrilaterals, and we had a whole bunch of different quadrilaterals. Remember, quadrilateral is a shape with four sides, okay? And so we had parallelograms, and inside parallelograms, we had rhombuses, we had rectangles, we had squares. Outside of parallelograms, we had trapezoids and kites. And so we talked about how those things were similar, what made them special, okay? But we didn't dig into it as far as we could. So we need to write some proofs to be able to prove some aspects about certain parallelograms or parallelograms in general so that we can solve certain equations later on, and also so that we can be given some new statements and reasons behind those statements for further proofs along the way. Okay, so our first proof says that I've been given that this shape here, A, B, C, D, is a parallelogram. Okay, and remember, a parallelogram is a shape, a four-sided shape, and the opposite sides are parallel. So I have my markings here that show that these opposite sides and these opposite sides are parallel, okay? So this is a parallelogram, and I want to prove that line segment AB is congruent to line segment CD, and that line segment AD is congruent to line segment CB. So I want to prove that these two lines are the same and that these two lines are the same, okay? Well, for any proof, remember we always want to start with our given statement, okay? So I have been given that A, B, C, D is a parallelogram, and that has been given to me. Okay. Now, I want to do something a little different that we haven't done yet, and that is sort of add something to my drawing, okay? So I want to draw a line between D and B, and I'll make it a dashed line so that we can really see it there so it stands out a little bit, okay? And I'm just going to write that I drew, so draw line segment. Now this is going to be line segment DB. And I can do that because between any 2 points is exactly one line. So that's my reason, is that between 2 points is one line. And that's going to help me out because I've split this parallelogram into two triangles, okay? And by doing that, I can use my triangular proofs. Remember the side, side angle side, angle side, all those to help me prove this even further. So all this is coming together into one thing, okay? So after I've drawn that line, now I can say that line segment AB is parallel to line segment DC. And I can also say, in the same one, I can also say that line segment AD is parallel to line segment BC. And this is the definition of a parallelogram. Okay, remember we said that was our main definition of a parallelogram. So definition of a parallelogram. Okay, so got that taken care of. And going back to our very first proofs, remember we had parallel lines cut by transversals. So we're going all the way back there for this next statement. And our next statement is that angle ADB, so angle ADB is congruent to angle CBD. So I have angle ADB, so this angle right here, okay, this angle right there is congruent to angle CBD, or this angle up here. And if I'm thinking of this dashed line as my transversal, I'm opposite or alternate sides of that transversal, and I'm inside my parallel lines there. So this is going to be alternate interior angle theorem. And I can also throw in that angle CDB and angle ABD are also congruent by the same theorem. So I'll also write that angle ABD is congruent to angle CDB. And that's the exact same thing. So I have A, B to D, and I'll do a double line here. So I have A, B to D, and then I have C, D, B. And those are, once again, alternate sides of that transversal inside my parallel lines, so alternate interior angle theorem. And those all go together there. Okay, so far I have an angle and an angle, so I have two angles. And then I also have that DB is congruent to DB. It's probably our easiest statement to remember. So DB is congruent to DB, and that is just reflexive. I'll just draw a little line there. Okay, so now I can prove that triangle ABD, triangle ABD is congruent to triangle CDB. So triangle ABD and triangle CDB are congruent because of angle, side, angle. So angle, side, angle. I'll extend that a little bit more. Okay, so I've proven that these two triangles are the same because of angle, side, angle. Now, I can prove that line segment AB, so my proof statement up there, so line segment AB is congruent to line segment CD, and I'll lump this one together because it's going to be the same statement, and that line segment AD is congruent to line segment CB. Okay, and I can prove this by what's called congruent parts of congruent triangles are congruent. And basically what this means is that if these two triangles are exactly the same, I can take this triangle up there, my ABD triangle, and I can put it on top of my CDB triangle, and it's going to be exactly the same. So if that's the case, then my line segment here of AB has to be the same as DC. BC has to be the same as 80 because they're the same exact triangle. I already proved that those triangles are the same. So that means that the congruent parts of the congruent triangles are congruent. So that means that this side is congruent to that side. This side is congruent to that side. So I've proven that line segment AB is congruent to line segment CD, and line segment AD is congruent to line segment CB. Now, this is an important proof because it tells me that a parallelogram, something important about a parallelogram, is that the opposite sides of parallelograms are congruent. Okay, so this is one of my statements now that I can use, and I'll write it down here, that opposite sides of parallelograms are congruent.